Hey everyone, I wanted to take a couple of minutes before the video lecture to discuss with you how things are going to wrap up for this semester. So we have three chapters that we have left to cover, which are the lymphatic system, the endocrine system, and the reproductive system. And what I'm going to do with these next 2 weeks is I'm going to actually deliver the information. Typically up to this point, I've been just putting material out for Thursday. I'm going to do this Thursday for the lymphatic system. Then I'm going to put out the information for the endocrine system. I'm not going to wait that full week. And then by next Thursday, I'm also going to put out the information for the reproductive system. Now, that might sound like a little bit of a lot of information or overwhelming, but here's the plan. I'm going to put all that information out and stagger it for you guys so that we can get through all the information, and then that last date that is set for class, that will be our test date. Now, that test date is going to be over those last three chapters. I'm not going to go back to the beginning of the semester. So that test is going to be over the lymphatic, the endocrine, and the reproductive. I don't want to be introducing brand new information and then the following day testing you on it. And so that's why I'm going to stagger these last three chapters over the next 2 weeks for you and kind of leave that last week for the actual test itself. So make sure that you are checking in your Blackboard, because you'll notice one extra thing pop up than what would have typically in the past. And like I said, I'm not trying to overwhelm you. I'm actually trying to eliminate a lot of information coming in that last week. And so we're just going to mix that in over the next 2 weeks for you and get that taken care of so that all we have to do in that last week is take the test itself. So the due dates that are going to be associated with everything are going to be pretty comparable to what they've been up to this point. So I'm going to put the information out there, but I'm going to give you a little bit more than a week to get those done so that you'll pretty much have right up until we're wrapping up class to get things turned into me. So even though you're going to have one extra thing, technically, you're going to have considerable enough time to get it done. Just please make sure that you're watching the videos and that you're taking care of the lab activities and things of that nature. If you find yourself in a spot right now where maybe you are behind or you missed an assignment and we need to get that taken care of, please send me an email. If you have the pictures and just haven't sent them of lab activities that you have done, but the due date passed and you feel like you can't submit it, please go ahead and submit it. I know that the situation is different than what any of us anticipated, and so I am willing to work with you guys on that. To me, getting you through the information is more important. I'm not saying that due dates aren't important, but I realize that this is much different than what we ever thought our semester would look like. And so I am willing to work with you guys. Just please make sure that you get that stuff to me so I can get that in the grade book. Now, the last three chapters that we need to cover are the lymphatic system, endocrine system, and the reproductive. And we're going to start out with the lymphatic. We're going to then move into the endocrine and end with the reproductive, as I mentioned. With the lymphatic system, a lot of people will refer to the lymphatic system as being your immune system. And while you can use those interchangeably, the most used term that is more technical is the lymphatic system. And so the reason that it's important to use the term lymphatic versus just immune system is if you say immune system, you are focusing on one of the things that the lymphatic system actually does. And so it pinpoints one specific area, but it doesn't look at the whole picture. When you talk about lymphatic, now you are talking about everything that is covered. And if you look at the very first slide of your packet, it is going to identify some of the major functions that your lymphatic system actually does for you. And if you look at that list, defending the body against illness is the very last thing on that list. You have quite a few other things that are going to be part of this. Now, when we talk about the lymphatic system, I think one of the interesting things about the lymphatic system is it's a vascular system. It is a series of vessels that run from head to toe. And a lot of times we talk about the cardiovascular system and everybody associates the blood vessels with the cardiovascular system, and we know that's vascular. But very few people actually realize that you have two systems in your body that work using a network of vessels that run through your body. Now, a couple of differences. In the cardiovascular system, your vessels run full circle. So if you were to look at your blood vessels leaving your heart, you could track them through the entire body all the way down to your toes and then back up to your heart again. So they make a complete circle and they keep coming back to the heart with your blood. The lymphatic system is a little bit different. It is a series of vessels, and what they do is they collect fluid from your tissues. So as your body is doing work, as your body comes in contact with different things, you can pull material in through your skin. There's all sorts of different ways that you can get this different type of fluid in your tissues. Once that fluid is in your tissues, you have to have a way to get it out. And that's what the job of the lymphatic vessels actually are, is they are going to run from head to toe. They find this fluid that is built up in your tissues. They will actually pull that fluid from your tissues and draw it into those lymphatic vessels. And then the lymphatic vessels are going to work to flush that fluid out of your body. This is fluid that you don't need. Sometimes it's a waste product from your cells doing work, and they will give off this excess fluid, and now it's just sitting in your tissues. Sometimes you can get it from things you come in contact with. If you clean your house without wearing gloves, stuff can leach in through your skin. If you draw on your hands, write yourself little notes on your skin, that can leach into your body. And once it's there, now you have to find a way to get rid of it. Even something that we don't even really think twice about, you go work out and you have sore muscles the day after, that's lactic acid that is built up in your muscle tissue. You have to have a way to remove that lactic acid, and that is going to be part of what those lymphatic vessels do. So any type of fluid, however it came to be in your body, those lymphatic vessels are going to collect it. Now, once the lymphatic vessels collect that fluid, now we have to have a way to get it out of our body. And so a lot of your lymphatic vessels will actually run right next door to a blood vessel. And by being next door to the blood vessel, there are two benefits to that. Number one, once that fluid has been collected in your lymphatic vessel, the lymphatic vessels actually are one directional. So they differ from your blood vessels that go full circle. Lymphatic vessels, they run one direction, which is in the direction of your feet. So there's a dead end. And if we don't get that fluid out of your lymphatic vessels, it's going to pool in those lymphatic vessels and your extremities will start to swell, starting at your feet and then working your way up to the ankles, the calves, and depending on how severe it is, it will continue to move up the legs. So the body has to get that fluid out of the lymphatic vessels. And by being right next door to your blood vessels, the fluid in your lymphatic vessels will diffuse over. So it passes out of your lymphatic vessel, moves into the blood vessel, and now that fluid is in your bloodstream. Well, what's the great thing about that? The great thing is those blood vessels are eventually going to run through your kidneys. Your kidneys will filter it out, and the next time you go to the bathroom, it's removed from your system. The other benefit to working right next door to the blood vessels is that the lymphatic system does not have a pump of its own. Circulatory system has the heart, keeps the blood moving forward. We don't have that in the lymphatic system. It has to depend on other things in order to keep the fluid moving through the body. And so what that is being next to those blood vessels, as the heart beats, your blood vessels will expand and contract with that heartbeat. And because they're right next to each other, as that blood vessel expands and contracts, it pushes up against the lymphatic vessel, and that pushing will help keep the fluid moving forward. The other thing is being in your muscle tissue. So the lymphatic vessels will run very close to your muscles. And again, as you're up and walking and moving, those muscles contract and expand. They push on those lymphatic vessels, and that will also assist in keeping the fluid moving forward. So as that fluid gets cleaned out, like I said, the goal is to get it cleaned out before it ends up in the lymphatic vessels in your feet. Because if there is any problem in getting that fluid removed, now it starts to build up. So if we don't get it out of those lymphatic vessels, it pools starting in, like I said, the toes, the feet, and working its way back up. So when you have somebody, sometimes somebody that suffers from being overweight, that exchange of fluid becomes more difficult, and you'll see their body parts or in their lower area start to fill up with that fluid. In some cases, it can get so extreme that there's so much fluid that is built up in the body that it will actually weep through the skin. And that is an extreme measure that the body would use to try and get rid of that fluid when it has no other way to get it out of the body. The other big thing that the lymphatic system will do is it moves fat to the bloodstream. We hear so much about fat being bad and having fat in the blood, it will clog the heart and the arteries and things like that. You do have to have fat in your diet. And getting that fat into the bloodstream is going to allow that fat to be distributed to where it actually needs to be used. Having the right amount of fat and the right type of fat in the blood is beneficial to what our body needs to do on a daily basis. But if you have too much fat or if you have the wrong type, then it becomes a health concern. But the job of the lymphatic system is to help get that fat into the bloodstream so it can be delivered to the parts of the body where it's actually going to be put to good use. And then the final one is the defense of the body against foreign illness. And we'll spend some more time talking about that later in the lecture. So if you look at the second slide, this is a picture, you have one in your textbook as well, of what the relationship between the lymphatic vessels and the blood vessels would look like. So your blood vessels here are the blue, the purple, and the red. So you can see a vein, the blue, the capillaries purple, and the arteries red. So the green vessels that you guys have are the lymphatic vessels, and you can see how they run right next to each other and how it would be very easy for that fluid that has been collected and is in those lymph vessels to be able to diffuse over into the bloodstream, so ultimately it can be removed from the body. You also can see on these pictures that the lymphatic vessels do come to an end. They are dead-end streets, so to speak. And so if that fluid is not removed and it gets to one of those dead-end streets, getting that fluid eliminated becomes problematic. The third slide that you guys have talks about the lymphatic vessels. I've already kind of gone over this a little bit. I didn't talk about the layers, but I put it in there because this is a trend that we have seen already. We've talked about places in the body where you have those three layers, an inner layer, an outer layer, and then the middle one. And the reason that I included it here is because when we talked about it before, I reinforced that design of having the inner outer layer and that middle layer being the muscle. And that is typical of what we see within the lymphatic vessels here. Talked about it moving in just one direction. And just like with our blood vessels, you do have valves in your lymphatic vessels because you want to make sure that once that fluid has moved to a certain direction or has gotten to a certain point, that it cannot move backwards and that it's not allowed to pool. So keep it moving forward, running up against those blood vessels so it can get removed from the system. The next slide that you have talks about the lymph fluid itself. And again, I've kind of already hit on this, but the lymph fluid, the one thing that you need to understand is that lymph fluid is different from one person to the next. So depending on your diet, depending on what you come in contact with, things of that nature will ultimately determine what type of fluid and how much fluid you have in your tissue. So it's not something that is the same from one person to the next. And even within an individual, it will vary from one day to the next based on what you're coming in contact with. So the next slide that you have shows you the lymph function and shows you the flow of lymph through the body. And with this particular setup, you can see that everything is one directional. If you look at the arrows that are on that picture, you can see that as that fluid is moving into the lymphatic vessel, that it's going all in the same direction ultimately. So once it's all collected and put together, it's going to be moving in one direction. And I cannot stress enough that getting that fluid removed from the lymphatic vessels is going to be very, very important because once it gets to those dead end streets, the end of the road within those lymphatic vessels, if it hasn't been removed, then it starts to build within the body. The following slide that you guys have talks about how lymph moves, and it talks about hydrostatic pressure. And what this is actually looking at is within the body. It's not just the muscles and not just the blood vessels that are going to help move it in a forward direction, but getting that fluid to diffuse and move into the lymphatic vessels themselves. How that actually is going to work is based on proteins. And when we talked about our movement of fluid, we talked about diffusion and osmosis and all of those very early in the year. And I realize that that's been a long time. But one of the things that we talked about was things like to move from an area of high concentration to an area of low concentration. And that's basically how the movement of lymph is going to work so that we can get it in and out of the tissue and the lymphatic vessels. So when we talk about hydrostatic pressure, like I said, that was not a term that we've introduced up to this point, but just like I said, going back to those concepts that we talked about very early on in the year explains how that fluid is going to move from out of those tissues and then into the lymphatic vessels where we actually want it. The following slide that you guys have talks about lymph nodes, and lymph nodes are going to be these tiny little nodules that you guys have all throughout the body. And with the lymph nodes, the average person is going to have somewhere in the neighborhood of 600 to 700 lymph nodes from head to toe. And a lot of times with pictures, for some reason, when you start to get into the hips and below, though, they're going to make it look like there are no lymph nodes in those lower areas. But you do have 600 to 700 in the average person. They do exist all the way from the head all the way down to the toes, because lymph nodes are going to be these tiny little places all throughout the body that are going to trap foreign particles. So something that the body doesn't recognize, what we do is we actually force the lymph through these lymph nodes, and they're basically tiny little filters. They are going to filter through that lymph fluid, and if there's anything there as like a virus or a bacteria or any other particle that somehow managed to get into your body that the body doesn't recognize, it will hang on to it. And the reason that it hangs on to it is because if it's a potential hazard to your health, you don't want it to continue to circulate all throughout your body. So these tiny little lymph nodes hang on to it, and they will continue to hang on to it until we can get the right cells there to break it down, destroy it, and make sure that it can't do any harm to the body. Now, if you are sick, one of the things that the doctor will do is they will fill your throat when you come into the doctor's office. And what they're actually looking for is if those lymph nodes in your neck are like tiny little rocks, that means that they are jam-packed full of foreign bodies, whatever those foreign bodies might be. But it's an indication that you are sick, that you have something in your system that's not supposed to be there. And those lymph nodes are just absolutely overloaded and hanging on to all of those foreign bodies until they can be destroyed and not do harm to your system. Now, with the lymph nodes, you have clusters all throughout the body, 600 to 700 total, but you'll have certain places where you have a cluster, a high group of them, high numbered group of them all together. And there are three major places where that happens. In the neck, which I just mentioned, that's why the doctor will check that when you first get to the office, the groin, and then the armpit region as well. Now, the reason that those are the places where we will see the highest clusters of lymph nodes is because those are the three places where you are highly susceptible to an invader. Now, with the neck, you have the ears, you have the nose, you have the mouth, and in some cases, things can even come in through the eyes. So you have a large number of places in which foreign bodies can get in within the head. And so that is a good place where they would eventually all funnel to. And that's why we see a high number of lymph nodes in the throat region. Within the groin, again, this is a place where you have openings to the outside world. In the male body, you would have 2 openings. The female body, you have 3 openings. And so while we typically think of things leaving the body in that region, it does potentially pose a risk for material to get in as well. And so with invaders being able to get in those 3 regions, it's another place where you want to have a high number of lymph nodes. The armpit itself does not have any openings to the outside world, but what it does have is the perfect conditions for foreign invaders to breed and grow. If you think about your armpit, it is typically a dark area. We don't spend a lot of time with our arms raised up over our heads. Usually our arms are down by our sides. So it's dark, which creates warmth and also creates moisture. Dark, warm, moist areas are very good places for foreign invaders to breed and grow in number. And because of that reason, that's another place where we would see a large cluster of lymph nodes. Now, the reason that the doctor goes for the neck is because that is the easiest place for them to check. Groin area and the armpit, especially like in the winter, if you live in Iowa, we are bundled up in sweaters and long pants and jackets and things like that. They're just a little bit more difficult to gain access to. And so the neck usually is the easiest one to check. The next slide that you guys have shows the location of the lymph nodes, and it shows you some of the other cluster areas, but keep in mind that the neck, the armpit, and the groin are going to be where you have the highest clusters. Now, in this particular picture, they show the lymphatic vessels running all the way down to the feet, but they don't show any lymph nodes past the hip region. You do have lymph nodes all throughout because you never know where an invader is going to get in. You could be walking around in bare feet and step on a rusty nail, and that is going to now be a new site of where foreign invaders can get into your system. And so you would have lymph nodes in that area as well. The job of lymph nodes, we talked about those lymph nodes and what they're doing. And with the lymph nodes, when you talk about the tonsils are the largest lymph nodes that we have in the body. And so they are so much larger than the other lymph nodes that you have, they actually get their own name. After the job of lymph node slide, you should be looking at one that talks about the thymus gland. Now, the thymus gland is a very interesting gland that we have within the body, because most times in the human body, when you talk about development, you start out as a baby, you grow up, and your body parts get larger. Your organs increase in size, your muscles increase in size, and this is one structure that actually will decrease in size as you age. Now, the thymus gland is going to be responsible for training your white blood cells. Your white blood cells are your defenders against invaders. And so what happens is when these white blood cells are being formed, they will travel, they'll originally start in your bone marrow. So your red blood cells and your white blood cells both are formed initially in your bone marrow. Now, the white blood cells, some of them will stay in the bone marrow and mature there. A special group of your white blood cells will actually travel through your bloodstream up to the thymus gland, and they will get training in the thymus gland. If you've ever heard of a group of cells called T cells, that's what they are. They are the group of white blood cells that went to the thymus gland to finish off their training. And they took the T from thymus and made T cells. Now, what happens is your T cells are going to train groups of your white blood cells on how to fight specific infections. So when you go to the doctor and they give you a vaccination, you get your MMR, mumps, measles, rubella. What happens is in the vaccination, they give you the actual mumps, the actual measles, the actual rubella, and it's in these in this material that's been that has been basically blended up. So they take the viral cells, they put them through a blender, they chop them up so they can't do any harm, and then they give you those small fragmented chopped up pieces. It's just enough that when they inject it into your body realizes this is something we didn't make. And so it will send these T cells to these foreign bodies, and it will allow the T cells to learn everything it can about these foreign bodies. Now, what happens with your T cells is they learn how to fight off one infection and one infection only. So you have a group of T cells that is completely devoted to fighting off the chicken pox. You have a group of T cells that is devoted to the mumps, and you have another group that is devoted to every common cold that you have come in contact with. So any illness that you've had throughout your lifetime, you have a very special group of T cells that are devoted to fighting off that specific illness and only that illness. So that the next time you come in contact with it, you already have this army of white blood cells ready to go and fight it off. And that's why you get the chickenpox once and you typically don't get it again, because those T cells immediately go to work, fight it off, and you never even realize that you came in contact with it again. But as you get older, and most of us will stay in the same place. So if you're born in the United States, you might move around from one state to the next, but typically you're probably going to stay in the United States for your entire lifetime. After a while, you don't come in contact with any other illnesses. And so the thymus has no new T cells to train. And as they are not getting any new T cells to train because you've come in contact with everything or most things, that thymus will start to shrink. And it will shrink to the point that you will eventually no longer have a thymus. So when you hit about 60, 70 years old, you probably no longer have a thymus. It is absorbed back into the body, replaced with a pocket of fat. So where the thymus used to be, there's now fat, but it sits behind the breastbone. So you don't notice that fat pocket that's developed because it's behind your sternum. So in a child, very large thymus gland. As you age, it decreases in size. You live long enough, you will eventually no longer have a thymus because it doesn't have a job to do anymore. The next slide that you guys have is the spleen. And the spleen is one of the three major filters that we have in the human body. So the three filters that we have are the spleen, the liver, and the kidneys. And if you think about where they are, we've talked about all of them at this point, but the liver is midsection and pretty much middle of the body. Kidneys are to the back of the body, but again, pretty much on point with where the liver is as far as height. And the spleen sits across from the liver on the other side, tucked just behind the stomach. So the three filters of the body are right around your midsection. Nothing in anatomy happens by chance. So why would that make sense that our three major filters are going to be pretty much center of the body? And it goes back to the idea that you have no idea when, where, or how an invader is going to get into your system. And once it gets in, it will hitch a ride in your lymphatic system. It will hitch a ride in your bloodstream. Any way that it can, it will start moving through your body. So by having these filters that are going to clean out your blood, it doesn't matter if that invader came in through your foot because you stepped on a rusty nail, or if the invader came in through your nose, your eyes, your mouth. By having those three filters in the middle of our body, if it's circulating down or if it's circulating up, it's going to spend the least amount of time in our body possible before those filters pull it out of our bloodstream, pull it out of our lymphatic system, and prevent it from continuing to circulate through our body. It ensures that it comes in contact with the fewest number of cells and fewest number of body parts possible before it gets filtered and cleaned out. Now, it's not a foolproof system. We've all gotten sick at some point in our lives. But if you could see what you actually come in contact with on a daily basis, you would be absolutely amazed at how little time we actually spend sick during our lifetime. If you were to take just a square inch of your skin right after you get out of the shower, you are going to have microbes, hundreds of thousands of microbes within that section of skin. We have natural microbes that live on our body. It's how we build our immune systems. So coming in contact with foreign invaders in small amounts is okay. It's how we build our system up to begin with. But there are going to be times where we come in contact with a large amount, especially if it's something that our body hasn't seen before. And in that case, sometimes those illnesses do get the upper hand and we do get sick and we run fevers and whatever other symptoms come along with that illness. But like I said, on a daily basis, if you guys could see what you actually do come in contact with, our immune system is our lymphatic system is pretty amazing at what it is able to prevent us from getting ill from. So those T cells that I mentioned earlier, one last point on those, and it leads into the last slide that we have, which is autoimmune diseases. Autoimmune diseases are going to be those illnesses which are somewhat self-inflicted. If your body loses the ability to recognize a cell or another structure that you made, it will start to attack it. So typically we have a recognition system within our own body where we can recognize cells that we made, and so our immune system leaves them alone. In some cases, though, there's a breakdown for whatever reason. It can be genetic, it can be environmental, it can be for a lot of different reasons. But our body loses the ability to recognize something we made and it will attack it. When we talk about HIV, HIV is an autoimmune disease, auto meaning self. So we attack ourself. But in the case of HIV and AIDS, it is an autoimmune disease that attacks the T cells. And so your body will find your T cells, actually attacks them, kills them, and gets rid of them. Well, what are we doing by doing that? If you have groups of T cells that are trained on how to fight off every infection you've come in contact with and you start eliminating them, you now don't have a defense against chickenpox. You don't have a defense against mumps, measles, polio, anything else. And so a lot of times you will hear people that have HIV or AIDS, they don't actually die from AIDS itself, but they die from a common infection because their T cells were wiped out and they don't have those T cells to defend them any longer. So if you look at that last slide that we have in the packet, and I'm not going to go through each one of these, but I wanted you just to look at some of the common ones. These are diseases in which somebody will start attacking themselves, and it talks about, gives you the name of the disorder, talks about some of the symptoms that are going to come with that, and then what the body is actually attacking and going after. Rheumatoid arthritis is one that people hear a lot about, and that's where your body loses the ability to recognize your own cartilage. So arthritis, a lot of people get that, but it's usually later in life and it's usually in a specific area because it's a body part that they used repetitively over an extended period of time. In the case of rheumatoid arthritis, you lose the ability to recognize your cartilage and it will attack cartilage anywhere it finds it in the body, and it typically happens much earlier. You're talking late teens and 20s where people will start to have the effects of rheumatoid arthritis. So it's much different than typical arthritis that you would hear about. So that kind of wraps up our conversation on the lymphatic system. And I'm going to do a separate short video to kind of talk about what activity you guys are going to do for this week for the lymphatic system.